Okay. So we're going over essentials of circles today. So we just took chapter 12 and broke it down to like 4 sides of lessons. So we're going to spend today and the next class working through this. And so I'm hoping to go over what I think are the most important parts of this. And I think we just have to do like 2 sides today and then we'll be good. Maybe even a little less than 2 sides. We'll kind of see what goes on. So let's start with some definitions. Do you remember what we call a segment whose endpoints lie on the circle? What do I call this?
Hold on. Is it in our chord?
It's a chord. Chord. Okay. A line in a plane of a circle that intersects it in exactly one point is what we call a tangent. You do not know this word yet, but we call a line that intersects a circle at exactly one point a tangent line. So like this intersects at exactly this point right there. That is it. I know it looks like, bless you, I know it looks like it intersects at more than one, but like we have to just realize that it's like super, super, super close to it and not quite there. So we call that tangent.
Like anytime there's like a triangle or like a shape on the outside, like how there's like sometimes it's outside circle.
It touches at exactly one point. They're all tangent to it. And then that point that the line and the circle intersect at is what we call the point of tangency. No, the radius, the vertex, no. The center is still in the middle of the circle, but the point of tangency is the point that they intersect at. And then last, it says a line that intersects a circle at exactly 2 points. Again, this is a new word for you. This is called a secant. A secant is essentially a chord that just goes on and on and on. So our chord has endpoints, so it finishes, it ends. A secant would go through the triangle and it would keep going and keep going. So it intersects at this point and this point, but it keeps going outside the shape. So we knew about chord before this. Now we're kind of adding 2 more lines that are important to our shape. Okay. So what we're going to do is we're going to do an example problem. I've got this picture right here, and we're going to decide what all of these lines and segments are, if they're chords or secants or tangents or diameters or radiuses, all of this circle. You ready to do it? Okay, HC. What would we call HC? Radius. Radius is the best word for that. Okay. What about BE? A chord. Why is that a chord, not a secant? It
not,
ends.
Yeah, it's not intersecting anything.
It does intersect technically at B and E. We would call those intersection points. But I like, Brayden, you said that it just ends. So because it doesn't have arrows on it, BE is a segment. It doesn't continue on and on and on forever. It's just a chord. What about BH? Diameter? Is there another word we could use? Diameter is the best word, but is there another word you could use instead of diameter? BH? Luis? Chord. You could call that a chord. So the reason it's also a chord is just a segment that goes through the goes through the circle and has endpoints on the circle. So it's a diameter is a special type of chord. So, but chord also works. What about line DG? Line DG. Tangent. What's its point of tangency? E as an elephant. So DG is my tangent line. And its point of tangency is E. What about AF? And let's put arrows on the end. Let's pretend like it goes on and on forever. I'm going to still call AF as secant because we're talking about the line that goes through the circle and doesn't end. So lines don't end. So we're going to call that a secant. A chord is a segment, so it ends, and a secant is a line, so it goes on forever. let's do some sometimes, always, never. All of our favorites. A diameter is blank a chord. Always. It's always a chord. Always. A radius is blank a chord.
Never.
Never. Why not?
Because it like in the middle.
Mhm.
Kind of, so like it has to be like on the outside.
Yeah, absolutely. Great job. You guys were able to get that together very cohesively. It doesn't go from end of the circle to end of the circle. It stops at the center. What about a chord is blank a diameter? Sometimes. That says sometimes. I know it doesn't look like it.
Wait, I have a question.
Uh-huh.
How is that sometimes but the first one's always?
So on the first one, I'm talking about the more specific thing. So a diameter is the more specific thing. So a diameter is always a chord. That's like a golden retriever is always a dog, right? You would not argue that because the golden retriever or the diameter is more specific. But number 3 says a chord is blank a diameter. The specific thing is the second thing. So if I say a dog is always a golden retriever, is that true or false? Or is that sometimes, always, never? That's sometimes, because you could think of like a bunch of other types of dogs, right? So I think about where's the most specific thing. If it's first, then it's always, and if it's second, it's sometimes.
Sometimes.
Mhm.
Oh.
Yeah. What about a tangent is blank a secant?
Never.
Why never? That's not
It
true.
only has one like point.
Good. And what about a secant? How many points does it have?
Oh, 2.
2 points. Very good. So a tangent by definition only intersects the circle at 1 point. A secant intersects it at 2 points. There's no way I could intersect it both at 1 and at 2 points. It just doesn't work that way. All right, now we're going to do a variety of theorems, and then we're going to solve problems based on those theorems. So the first one, it says, if a line is tangent to a circle, then it is perpendicular to the radius drawn to the point of tangency. Okay. So if a line is tangent to the circle, so like let's say this line L is tangent to my circle Q, then what 2 things are perpendicular? I would say line L, the line is perpendicular to the segment QP. So L is perpendicular, L is tangent at point P. So that means the radius that goes from the center Q to point P on the circle, that radius is perpendicular to the line. Okay, and then vice versa. This arrow sign means that we can go either way. So that means if I know, then the converse, if a line L is perpendicular to QP, then L is tangent to the circle Q. The reason that is helpful is because we spent several units studying triangles. So if we can make something a triangle, or more specifically a right triangle, we're going to be able to solve a few more things out than we were used to. Okay, so all of these problems are reliant on the fact that it is perpendicular, or we're asking ourselves, could it be perpendicular? So let's say this. It says ED is tangent to circle O. What is the value of X? So X is this angle right here. 38 is this angle over here. And then if I say ED is tangent, what does that mean?
It intersects at a point.
It intersects at a point, and how does it intersect? Just normal intersection, just crosses each other? Does it make a specific angle?
It bisects.
Does not bisect. 90 degrees. So ED, this line, is tangent to the circle. So that means at point D, I have a 90-degree angle.
36.
38, 90, and something else. So we have to find this missing angle. How do you vote we find that missing angle?
Well, you got 90 plus 38.
Perfect.
62.
I think 52. I know, the 10s are hard. So hard. So hard. All right, so what we learned is because it says tangent, that means that I can draw a right angle there. I don't get to draw the right angle there just because it looks like it. I get to draw it because it says the word tangent. All right, so let's do the one next to it. It says, what is the radius of circle O? Okay, so I've got X and X labeled. I have this right angle, which means that it's tangent, which is good. How is that going to help me, though?
Well, wasn't that when two sides congruent?
Not two full sides. It makes one's full side and then part of another side congruent. What can I do with a right triangle? Could I find a missing side? Yeah. What method would I use? Yeah, we're gonna use Pythagorean theorem. What's your hypotenuse here? Why? We have to do that whole side. I have students sometimes who want to say it's 6x. It's not 6 times x, it's 6 plus x or x plus 6. I don't care which way you write it. There must be a plus sign between them. That's your C, that's your hypotenuse. So we're going to say x squared plus 10 squared equals x plus 6 squared. And make sure you put it in parentheses like I did. All right, so I've got x squared plus 100 on the left side. How do we do x plus 6 squared? How do I deal with that?
You do
Bless you.
to both, since it's in parentheses.
Then doesn't it become?
Oh.
Don't forget to FOIL. We want to just do x squared and 6 squared, but don't forget that middle term. X squared, so that's plus 6x, and then plus 6x plus 36. So I've got x squared plus 100 equals x squared plus 12x plus 36. Now what?
Now you can subtract 36 from both sides in x squared.
Okay, 36 goes away, so 100 minus 36 is 64. And then x squared minus x squared is 0. X squared minus x squared is 0. So 12x equals 64. Divide by 12. I think it becomes a weird decimal. Yeah, I think we got, about 5.3 repeating. It's fine.
Yeah.
Mhm.
So then, how do you find the radius?
Well, this is x. What is x? The radius. So we labeled my radius as x, and so once I found my x, that is my radius, so we're done. Oh, sorry. All right, can we keep going? Next one says, is ML tangent to circle N? Is this tangent? If this were tangent, what would be true? What would I be able to draw in my picture? Where?
On
And
L.
At L. NLM, you could have said that. I would have been okay with that. Or MLN. NLM, MLN. Those are too similar for me. That would have to be there. So then that means what would be true?
30, 60, 90.
Not necessarily. We don't know any other angles. What do we do when we only have sides? Pythagorean theorem. Now, we normally do that when we're missing a side. We're not missing any sides. Those girls are having so much fun. Something is funny. So I want to see if this is going to be true. My 25 is my hypotenuse. So I'm going to ask myself, okay, is 7 squared plus 24 squared equal to 25 squared? You will not find x. We will just see if this is true or not. And if it's true, then we're going to say, yeah, it's okay. These are tangent. And if it's not true, then we're going to say, no, this just doesn't work. So 49 plus, I don't know what 24 squared is.
It's 576.
576. And 25 squared is 625.
650.
Oh.
Yeah, oh wait, no, you're right.
Okay.
I don't know what I did.
That's okay. So I'm gonna add 579 plus 49. 576 plus 49. I don't know if I said that right or wrong. Oh, and that's 625. So is this shape tangent?
Yeah.
Yeah. So is it tangent? I'm gonna say yes. That's my answer. Yes. All right. Last one on this page. ML and MN are tangent to circle O. What's the value of X? Why did they tell us they were tangent?
Intersect.
They intersect what at a point? I'm okay with that. What have the last four problems meant with tangent? What have we drawn on all of these pictures? 90-degree angle. So where am I going to draw a 90-degree angle at?
On N and L.
N and L. So we're going to draw 90-degree angles there. Is that enough information to help you figure out what X is?
Yeah.
Yeah, what do I do?
180 plus 117 plus X equals 360.
Good. I like that you added your 90s together before, so I didn't have to write 90 twice. And that adds up to what? Did you tell me? 360. Okay. So 180 plus 117. That's 297. And if I do 360 minus 297, I get 63. Because it tells me that they're tangent.
Tangent means right.
Tangent means 90 degrees. Tangent means right angle. Tangent means 90 degrees. All right, next page. We've got two more theorems I want to do. We can stop by this third theorem. Okay. The next theorem says if two segments from the same exterior point are tangent to the circle, then they are congruent. So if I have segment SR and it is tangent to my shape, and I have ST and it is also tangent to my shape, then RS and ST are congruent. So if SR and ST are tangent, then that means SR is congruent to ST. That's kind of fun. Let's see if we can figure that out. Circle O is inscribed in triangle PQR, which has perimeter of 88. What is the length of QY? Okay. So I know from point P, I'm tangent here at X, and I'm tangent here at Z. PX is 15, so what does that make PZ?
15.
15. Okay.
Equilateral.
Is there any, I don't know if it's equilateral. Is there any other side that I can figure out just like I figured out that side was 15? Yeah, Ella? YR would be 17. Very good. Now, are these bisected? Like was PR, was that a bisected segment?
Yeah,
Not bisected, I would not say. Why not, Caroline? It doesn't have the lines, but I can think of some other reason too. Why is it not bisected? Anyone know? See how this is 15 and this says 17? If it was bisected, it should be the exact same number, right? And it's not the exact same number. So yeah, like is intersected, it's split, but bisected means cut into two equal pieces, and it's not cut into two equal pieces. Okay, I don't know what QY or QX is, but I do know that all of the pieces add up to 88. So let's throw a variable in for those two. Let's just make it X and X, and then we'll find that out in a second. And so I'm going to do 15 plus 15 plus 17 plus 17 plus X plus X. And that's going to equal the perimeter they told me, which is 88. $15 plus 15 plus 17 plus 17 is I think 64. At least last year I got 64. Plus 2x equals 88. Minus 64, I get 24, I think.
2.
And then x equals 12.
So they both equal 12.
So then both of those little segments equal 12. Is that what they asked me?
Yes.
Yeah.
Yeah, they asked me the length of QY and I found it. It's 12. All right, cool. Let's do the next one. Similar idea. It says it's circumscribed about J. That means all of those points are tangent at that point. So the perimeter is 18. Find X. All right, what else can I label? What other segments do you know here?
Wouldn't CR be 3 as well?
Yep. What else?
SD would be.
SD is 3.
So then
Are there any other sides I can label?
Yeah.
would B be 3 as well?
We don't know that for sure. Oscar, what else do you want to label?
Yeah.
What'd you say? What's 3?
TA.
No, TA is X.
Oh yeah.
If TA is X, is there anything else I could label X maybe? Yeah, Caroline? TV is X, and is there anything else that's X? BU, good. So now I want to label all of the outside if at all possible because I want to add it all together to be 18. So I've got 1, 2, 3, 4, 3. So I'm going to say 3 plus 3 plus 3 plus 3 or 3 times 4. And then I have 1, 2, 3, 4 X's. So I'll say plus 4X equals 18. You can write X plus X plus X plus X and 3 plus 3 plus 3 plus 3, but that feels like a waste of time. So I'm just going to keep it here. 3 times 4 is 12, and when we do 12 minus from 18, we get 6. And then divide by 4, 1.5. Okay. One more like these. All right. AB is tangent to C at point B. AD is also tangent. Find the value of X. What do we know about AD and AB? They're congruent. That's congruent to that. So how can I set up an equation to solve?
X squared plus 24 equals 49.
Perfect. Minus 24, x squared equals 25, I think. And what's the square root of 25? 5. Good. I am going to throw a plus or minus in here because my question gives me x squared and no other x's, so it could be negative 5 squared. All right. Awesome. You ready for the last theorem for today? Anybody have any questions so far? Okay. The last one says in the same circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding chords are congruent. So arc AB is congruent to arc BC if and only if segment AB is congruent to segment A or BC. So if the chords are congruent, then the arc lengths and arc measures are congruent. It goes the opposite way too. So if I tell you that the chords are congruent, then I know that these arc lengths and arc measures are congruent. All this is helpful in telling me is like what can be set equal to each other and what cannot be set equal to each other. I said that's BC. I know it's kind of funny. The C went down really far. Okay, let's do an example. Okay, so we want to find arc measure of AB. All right, my chord AB is 16. My chord DC is 16. If my arc measure CD is 108, what's my arc measure for AB? 108. That was so easy, right? Measure of arc AB is 108. All right, let's go over here. It says in the figure, circle J is congruent to circle K, and MN arc length is congruent to PQ arc length. So find PQ. Set those equal to each other. So 2x plus 1 equals 3x minus 7. Minus 2x, I get x. Add 7, I get 8. If x equals 8, what's PQ going to be? 3 times 8 minus 7, which is 24, minus 7, which is 17. Yeah, very good. I got one more problem. You guys ready? Awesome. This last one says circle P is congruent to circle Q. And I know that RS is 155, and I know the major arc TU is 205. And I want to find X. Why are we allowed to do that? How do you know that? The whole circles are congruent. That doesn't mean that the segments are. What'd you say, Oscar? They're opposite each other. So if this is 155, what's this segment?
205.
Do those all add up to 360? Yeah. And so if that's 205, then this becomes 155. So because we know that the angles add up to 360, so essentially the arc measures are congruent, that's why I'm allowed to do 7x minus 44 equals 3x and solve there. So minus 3x, and I'm going to add 44, so I'm going to get 4x equals 44, which means x is 11. X is 11. All right. All right, let me show you your homework. I believe it's the first circles homework. So there's a homework. I want everybody to look at me, look at me, look at me. It says homework circles part 1. It's a front and a back, and I want you to do both the front and the back. Front and back. There's only 2 little questions on the back, but you still have to do those 2 little questions on the back. Okay? We'll do circles part 2 another day. And then that will be all the homework for that chapter. Anybody questions on anything? Okay, I'll stop recording.